COMP9418. I'm Gustavo Batista. I'm the lecturer in charge for the course. And in this welcome video, I want to explain to you a little bit about the organization of the course and the course content. So the first thing, what is this course is about? So this course is about probabilistic graphical models. And as the name suggests, it involves probabilities, graphs, and models. So we want to use probabilities as a way to represent uncertainty, and we want to create the models that will represent that uncertainty in order to make inference. And those models will use a common language that are graphs. So we're going to use this data structure that is so common in computer science in order to represent the model. So the nodes of this graph are going to be the variables, and the links between the nodes, we're going to be representing some dependencies among the variables. So we're going to have time to discuss in detail exactly what are going to be the variables and what are going to be those dependencies. But the idea is very interesting because this idea of probabilistic graphical models, it put together computer science and statistics, because those graphical models were created by computer scientists that were interested in using probabilities as a way to represent uncertainty. That's also very important for solving practical problems. But they have some issues, and the statistical inference was developed so far to solve problems that were sort of small in terms of scale, but they want to solve those problems with hundreds, maybe thousands of variables. So this brings a very kind of a computational perspective to these models, because we want to have algorithms that operate over those graphs in a very efficient way. So I would say that this course is a joint between computer science and statistics. We're going to use probabilities from statistics as a way to represent uncertainty, and you're going to have algorithms operating over graphs that are going to answer queries to us, and also going to learn from the data. And also we have the models, and the models here are what we understand, right? So in machine learning, we want to create those models in order to make inference and answer questions about the future. So we want to learn from data that is the past in order to make inference and answer some questions about the future. What I like about the probabilistic graphical models is the fact that it's a kind of a common language, common framework that we can understand the different models. So we're going to touch different things as we go through the course. So we're going to use those graphical models to explain what is a Bayesian network, and also what is a hidden Markov model, what is a Markov model, what is a conditional random field, what is a Kalman filter, and many different things. So it's a very interesting because it's going to give us a common language that we can explain different things using this same framework. All right, so I'm going to also discuss a little bit about the course organization. So the first thing that I need to note is the fact that we're going to use WebCMS in order to make the course content available to you. So everything is going to be available on WebCMS. The assignment description, the course material, the quizzes, and so on. We also have the forums when you can ask questions, and we're going to answer those questions to you. So WebCMS is going to be our main point of contact, right? I understand that UNSW also use Moodle, but we're not going to use Moodle during this course. The only exception is that Moodle has a link to Echo 360, and we're going to also make the videos available on Echo 360. But those videos will also be available on YouTube, so you don't need to use Moodle. But if you want to access Echo 360, you're going to go that through the Moodle page. Another important note here is the fact that we're going to run this course online. The last offer of this course, we have part of the activities online, part of the activities face-to-face. But because of the lockdown that we are now facing in Sydney, we have no other option but to make the course entirely online. The best I can tell you right now is that I'm watching here what's going to be the determinations from the New South Wales government and also from the university about how what we can do when the lockdown restrictions are lifted. So far, the best we can do is assume that the course will be entirely online. If the restrictions are lifted, we can have a discussion and maybe have some activities face-to-face. All right, so we have lectures and we have tutorials in the course. First, the lectures. I have recorded some videos explaining the course content. Then I'm going to make those videos available on YouTube. What I like about those videos is the fact that you can watch the videos when you have time available for doing that. The videos are sort of a short, maybe 20-30 minutes, and if you have that time window available, you can watch one of those videos. The bad thing about those videos is the fact that they are not interactive, right? So we cannot ask questions as you watch the videos. So we're going to have 2 different times during the week that you can come and ask questions. One are the traditional consultation hours that are going to run on Mondays, but we'll have something different on Thursdays from 12 to 1 p.m. that we're going to have a live lecture where we're going to discuss some problem. We're going to revise the theory that's necessary to solve the problem, and we're going to have some questions and answers there. So we have these 2 hours, consultation hours on Monday, and these lecture hours on Thursday, that we're going to have these discussions, and we also have the videos available on YouTube and Echo 360. The tutorials. So these are our tutors, Payol, Peng, Jeremy, that's also course admin. They will be responsible for the tutorials. These are the times for the tutorials. All tutorials will be on Microsoft Teams. So I'm trying to make the course as simple in terms of organization as possible. So we're going to use just 2 platforms. One is WebCMS for the course content and Microsoft Teams for the meetings. The tutorials, they have 2 parts. One is a theory and another one is a practical part. So one is basically questions that you need to answer those questions, exercises. And the second part is a Jupyter notebook where we're going to develop some code. It's a library for probabilistic graphical models. As we develop that library, you're going to see that this library is going to be very useful for the forthcoming lectures. So we're going to be useful for understanding the theory, as well as we're going to reuse some of the code in a future tutorial that you developed in the previous one, and also for the assignments. You're going to see that we build the assignments over those libraries, so you can use your code that you developed during the tutorials in order to solve the assignments. All right, let me scroll down here. So we have consultation hours, Mondays from 2 to 3, also using Microsoft Teams. These are traditional consultation hours that you can come, maybe bring the slides, ask questions, and I will try to answer your questions the best I can. Let me just scroll down here and let's talk a little bit about the assessment of the course. So the course has 3 main assessments. The first one are the assignments. They are worth 30% of the mark. We have quizzes. They are weekly quizzes. Start on week 2, jump in week 6, that is flexibility week, and 1 quiz per week, and they are worth 10% of the marks. And we have the final exam that are going to be worth 60% of the marks. So the assignments, they are practical assignments, basically programming assignments. again, we're going to pose a problem to you. You're going to use the libraries that you have developed during the tutorials to solve those problems. For the quizzes, these are very simple multiple choice questions. Basically, we use that to try to force you to keep up with the course content. So we don't want you to accumulate content. So every week we ask you a few questions about the content, and you need to answer those questions in the form of a multiple choice questions. Everything is very simple in terms of quizzes, just basically review questions that you can answer them very quickly. And we have the final exam, and the final exam is very likely to be online. Our exam usually lasts for 3 hours. We have a mixture of multiple choice questions, some open questions that you basically write in text answering the questions, and we usually have 1 or 2 very small programming questions that again you can use the code that you developed during the tutorials to solve those questions. About the assessment, the only detail that I should mention here is the fact that for the final exam we require you to have at least 24 out of 60 points. So that's the minimal mark that you need to have in order to be approved. All right, talking about the course schedule. This is a tentative schedule, but I'm quite confident that we can follow that until the end of the course. So we start with a course overview, talk a little bit about propositional logic and also probability calculus. So it's a very kind of a computer science view of statistics. So we're going to look at probabilities as a way to express uncertainty and expand logic. So logic, we cannot have uncertainty. Basically everything is true or false in the case of propositional logic, and we want to extend this language in order to express uncertainty, uncertain events. And we move on to Bayesian networks, and we talk about the representation, how we represent that. It's going to be a graph, and also what it means, that is the semantics. We can see here that I also mentioned in the chapters of the book. So we have a textbook that is this one here, Modeling and Reasoning with Bayesian Networks, from Adam Darwich. I really like this book. Very well organized, very clear. But unfortunately, it only covers the Bayesian networks. So we need to bring some content from other books. And in this case, we're going to bring some content from this second book here, from Kohler and Friedman, called Probabilistic Graphical Models, Principles and Techniques. This is also a very nice book, but not as easy to understand as the first one. So I follow the first one as much as I can, and I bring a little bit of content from the second one when it's necessary. So we move on week 3 to exact inference and Bayesian network as classifiers. So now we're going to touch a little bit of inference, one very simple algorithm for inference. So you're going to see that in the course we're going to touch 3 main topics. One is representation, one's inference, and the other one is learning. So we need to know how to represent the model. We want to make inference on top of that model, and the inference will answer the questions that we are interested about. And the final one is how we learn from data the parameters of those models. So exact inference, we're going to be our first topic, and we're going to take a look at how we can use this exact inference and the Bayesian networks in order to build some simple classifiers. We move on to Markov chains and hidden Markov models. That's basically applying those Bayesian networks when we have a problem that develops over time. So we need to incorporate the time information in the models. We talk about map inference. That is a different topic, and Markov networks. So Markov networks are going to be our second model. The first one, Bayesian networks, the first Bayesian networks, the second one, Markov networks. And the difference here is we are talking about directed graphs in the case of Bayesian networks or undirected graphs in the case of Markov networks. And Markov networks, again, have very different models inside it, and one of the main ones would be conditional random fields, very popular model when you want to integrate output of different classifiers in a structured way. So we want to classify an image, and we have classifiers that may be classifying part of the images, but we want to make it together in order to give a little bit of context to the classifiers. Week 6 is flexibility week, so we have a break here, and we move on to Gaussian Bayesian network. So basically we are introducing continuous variables here, and we talk about the joint tree algorithm. That is an algorithm for inference. It's a little bit more complicated than the variable elimination that we're going to see on week 3. We move on to belief propagation and sampling. These are two approaches for approximate inference. And we finish with learning the parameters and the graph structure from data. That's our final topic. Talking about the tutorials, basically the tutorials, they follow the lectures one by one. The only exception is that in the first week we talk about graphs. So I want you to revise the concepts of graphs and the main algorithms, and also build a small library for graphs that I'm going to use during the course. Apart from that, this second week here, we're going to be covering the topics of the second one, and keeping doing that for each week. We have here the two assignments, first and the second, and also the quizzes. All right. Also touch here the books. This first one, as I said, I like it very much. It doesn't cover all the topics, and we're going to bring a few topics from the second one. All right, that is my overview of the course. I really hope that you enjoy the course and learn something new, and I see you in week 1. Bye.